Mercury's special because it's the only metallic element that's a liquid at standard temperature and pressure. Its elemental symbol is Hg because it's based on its older and much harder to pronounce name. It used to be called hydrargyrum, which is the combination of the two Greek words hydror and argyros, which mean water and silver. The density of mercury is really high, so the small amount that I have here weighs a surprising 2.5 pounds. It's significantly denser than most other metals, so if we add something like a coin, it should float on top. Its melting/freezing point is around -39°C, so if we go below this, it's going to freeze solid. As it warms back to room temperature, it'll start melting, which I think looks pretty cool. It has a relatively low boiling point for a metal at only around 360°C. This makes it somewhat easy to purify by distillation, but I really don't recommend doing that, especially at home like I did, because it can be pretty dangerous. If something went wrong and boiling mercury spilled everywhere, it would be a disaster to say the least. Because of strong metallic bonding forces between mercury atoms, it has a really high surface tension. I don't want to go into much detail, but this causes the surface of the mercury to be drawn into itself in a way to minimize its surface area, ideally forming a sphere. In larger amounts, this isn't as noticeable because the effect of gravity is much greater than the surface tension, which causes the mercury to flatten out. However, as the volume decreases, the force of gravity gets less and less, and eventually the effect of surface tension can take over. When it does, it forces the mercury into a nearly spherical shape. Because it's a metal, it also conducts electricity, and this is taken advantage of to make various mercury-based electrical switches. There are many different designs, but the most common one is probably the tilt switch. If it's tilted in the right direction, the mercury will complete the circuit, turning on a light bulb or whatever the system is set up for. Mercury doesn't normally exist as a metal in nature, and it's usually found in the form of mercury sulfide, which is commonly known as cinnabar. Mercury sulfide exists in two forms, where one is red and the other is black. The red one is the most common, and because of its strong color, it was historically used as a pigment known as vermilion. Both of the forms can be converted to mercury metal, which is usually done by roasting it. With the strong heating, the mercury sulfide breaks down into elemental mercury, which is distilled off and collected. Although roasting it is the most common method, it can also be done chemically. Mercury sulfide is completely insoluble in pure water, but it can be dissolved in strongly basic solutions of sodium sulfide. Then, elemental mercury can be leached out of the solution by adding aluminum foil. The mercury that forms sinks to the bottom, which can be collected and cleaned up. An interesting property of mercury is amalgamation, where it forms alloys with other metals. Probably the most common example of this is the amalgamation of aluminum. Aluminum is normally surrounded by a protective oxide layer, but the mercury disrupts this and exposes fresh aluminum to the air. The aluminum quickly reacts and forms aluminum oxide, which grows as these white fibers. This releases the mercury from the amalgam, which can then go on to combine with more aluminum and continue the cycle. Even if all the visible mercury is cleaned up, some of it has seeped into the aluminum and it can continue to destroy it. This is the reason why you're completely banned from taking any amount of mercury onto an airplane.